Welcome everybody to our second webinar in the series. Today we're going to be talking about why is the maintenance factor important in airport apron lighting. Before we get started, just a little bit of basic webinar protocol for any of you who've not used Zoom in a while. So everybody is muted. It's only us who can speak. So if you've got any questions, please put them into the Q&A box. And we've also got the chat function enabled so you can say hello to everybody. After the webinar, we'll send out an email with a link to the recording. So if you'd like to rewatch anything or share it with any of your colleagues, you can do so. And any resources that we mentioned during the webinar as well will be included in that email. And once the webinar is over, there'll be a quick survey that will pop up upon exit. It's just 3 simple questions. We'd love to know how you think we've done today and anything you'd like us to cover in the future. So first off, I'm going to hand over to Yuli, who will do introductions to our wonderful presenters and a little bit about Midstream lighting for those of you who don't know us. And in the main presentation, we're going to be answering questions like, what is the maintenance factor? Why should you be using it? How is it calculated? And how do we check what the maintenance factor has been used? Over to you, Yuli.
Thank you very much. So Sophie, of course, very kind to kick us off, is our head of marketing and really is kind of the driving force behind this webinar Wednesday series, which has been popular in the past, and we just relaunched it again now, and hopefully you'll find lots of benefit from it. So my name is Yuli. I'm the co-founder and commercial director here at Midstream. So I have been involved in aviation lighting for probably about 12 or 13 years, really kind of working on all the projects that we have delivered in the past. We also have Natasha Collins, who's our international sales manager focused on aviation. Some of you would have already met her. If you haven't, I think you should, because she's great and has a lot of knowledge in apron floodlighting. And of course, Paolo Corno, who we've drafted in, or say parachuted in at the last minute to actually deliver this presentation, because during the practice runs, we realized there was a little bit more technical than we had thought. And so Paolo, who is a co-founder and technical director at Midstream, really has a wealth of knowledge, kind of a fountain of knowledge on all things to do with LED lighting, but specifically when it comes to high power floodlighting in applications such as aviation. So really excited to have him actually deliver this. For those of you that don't know Midstream or don't know us very well, we are a manufacturer, full cycle manufacturer of LED systems for apron airports. We are one of the very few companies in the world that are focused on this application. We've delivered over 150 global airport projects. So anything from South Africa to Iceland, and from South America, Ecuador, all the way through to Australia, New Zealand. We've done it all, from the hot climates to the cold climates, saline, and some from small projects like London City to some major airports and major hubs around the world. So we are, of course, able to deliver a full cycle system. So anything from the design of the master plan to detailed design of the lighting systems, and of course our proprietary luminaires, which are quite, I would say, unique to the market for in many ways. And then of course all the way through to providing a turnkey solutions with installation, with masts, with control systems, all the way through to providing consultancy and maintenance on these systems too. So really, the whole system is what we are experts in. Hopefully, you would have seen our systems before, but if you haven't, we're happy to, of course, re-engage after this webinar, which is designed to be educational in nature. We consider that one of the key areas that we can really improve around the industry is the improvement of knowledge. So raising the level of knowledge and education in the industry. And that's why these webinars are specifically designed from an educational standpoint and not from a commercial sales standpoint.
Wonderful. Thank you very much, Ely. So before we get started, we're just going to do a quick poll. We'd love to know if you know what the maintenance factor is and how it's used. So a box should be popping up on your screen with 3 options. And I'll just give you 30 seconds to vote. We'd love to know. Oh, I can see the votes coming in. Okay, wonderful. So as we suspected, I'd say we've got about half and half. Some of you have heard of it. Quite a few of you know what it is, but we've got a small percentage who don't, and that's great. Because today, hopefully, after this, all of you will be able to say, yes, you know what it is and how it's used. So now I'm going to hand over to Natasha.
Great, thanks, Sophie. So before I hand over to Paolo, who is going to explain in more detail what maintenance factor is, let me just quickly share why we've actually chosen maintenance factor as a topic for our webinar. So the same as our previous webinar that we did on CCT, maintenance factor we've seen become an increasingly asked about question and topic, whether it be consultants, whether it be project managers or airport operators. There seems to be a lot of questions and actually uncertainty about what it is and why it's used. So people that typically are asking us about best practice, why it's needed in a lighting design, and also actually just what it means. So hopefully today we'll be able to answer those questions for you. So Paolo, can you kick us off? And I'll hand over to you to explain what maintenance factor is.
Thank you, Natasha. So let's start with understanding exactly what the maintenance factor is. Then we're gonna move on to how it's used. Basically, the maintenance factor is a decimal number between 0 and 1, which you will hopefully often find on lighting plans. It is actually an extremely important number because it's technically the first input that you put when starting a lighting calculation, a lighting design. What this number does when inputted into a lighting calculation software is it will multiply all your results to this decimal number in order to simulate what would be the light levels on the last day of your lighting project lifespan. So sort of a reality check, a bridge between what it is on theoretical value and what you actually need to do in real life. This ratio, this number, is calculated following a specific guideline, which has been around since the early days of lighting designs. It has evolved throughout time with the change of technology. For example, the most standardized way of calculating is using the YESNA RP8 guidelines. What does this take into account? Takes into account different variables, starting from the product used, mostly due to the technology used. In our case, LEDs. There's not many lighting projects being done now with the discharge luminaires. And in the lumen maintenance, so the aging of the product. So how much lumen output will the product lose over its lifetime? Then a big part of this calculation is the quality of the environment. So both the temperature, the level of dirtness that will be accumulated over the luminaires, and the maintenance schedules, which will basically serve as an indication on how often do we restart with a perfect clean environment. So this is important to say that the maintenance factor is specific of a lighting project, not of a product. So you cannot say, oh, my product has a maintenance factor of 0.95. It's not such a thing. Maintenance factor is of a lighting plan, of a lighting project. The same product used in different environments and different projects will result into a different maintenance factor. let's see now more in practice why we need to consider it and what effectively it does. So when doing a lighting calculation, a lighting project, what we're doing is determining the number of fixtures required to carry out a certain task, to meet and fulfill a certain requirement. Of course, also the way they need to be installed, the aiming and all of that. But mostly the starting point is how many lights do I need to light this apron from this position at ICAO regulation. And one very important detail when doing this calculation is also determining how long am I going to be compliant for, because nobody is interested into understanding how many lights I'm going to need to be compliant for one day. I want to operate this apron for 10 plus years. For example, our standard way is considering the lifespan of a lighting project 50,000 hours. Then the product may exceed that lifetime, but the lighting project is valid for about 50,000 hours. So the maintenance factor that we apply to this lighting calculation is effectively what it's gonna determine how many fixtures we're gonna use. On a purely mathematical and practical level, if I use a maintenance factor of 0.9 when I use my software, the results that you see on the page where you have lighting levels for the apron have already been multiplied by that ratio. So if I have 20 lux, it means that on the first day, I had 20 lux divided by 0.9, so 22 lux. If I've used the maintenance factor of 0.5 and I have 20 lux, it means that on the first day, I expect to have 40 lux to start from, because maybe that is a particularly bad environment with a lot of depreciation going. So this is just to underline how important this little number is, because it is literally only written maybe once in a 100 pages document, but it makes a whole world of difference, both in the power that I'm going to be installing in an airport or actually in any lighting application, and how long I'm going to be compliant for.
Thanks, Paolo. So I think that actually brings us on nicely to understand how maintenance factor is actually calculated. So could you just walk us through the calculation?
Yeah, so the actual calculation is done by using these three parameters listed here, the LLMF, the LSF, and the LMF. All of these parameters come from multiplications of other, let's say, sub-parameters below them. So the actual calculation is quite lengthy. Starting from the lamp lumen maintenance factor, this is the representation of how much light will my luminaire lose over time just by working by itself. So, LEDs or before light bulbs will degrade over time. LEDs degrade for electromigration, for decay of the phosphorus in front of them. They lose efficiency over time. So there are standardized ways how to calculate in a perfect environment how the luminaire will decay over time, which takes into account the LED chip itself by running testing and projections by the LED chip manufacturers, which then release their data publicly with something called LM80. And then this value is plugged into a standardized calculation called TM21, which takes into account the remaining parts of the luminaire, for example, the working temperature resulting on how well your heatsink is designed. And this will deliver a curve to predict what the light flux will be at a certain amount of working hours over time. Then there is the LSF, which is the survival factor, because also the fact that components can fail over time needs to be accounted when you do a lighting simulation. Before, it used to be more related to the bulb. Now it is more related to the number of LEDs surviving after time in the matrix or the drivers. Often this is a number which is always going to be very, very close to 1, somewhere in the area of 0.99 and so on. The LMF, maintenance and cleaning intervals, is another number. All these numbers are always between 0 and 1, 1 being 100% and 0 being 0%. This LMF is a mix of 2 very important parameters. One is the LDD, which is the light dirt depreciation. So how dirty will the luminaires be over time? Because you can imagine physically masking something that emits light, it's the easiest way to drop the light levels. If I throw some mud on a luminaire, my light levels will decrease drastically. And the cleaning, the servicing, the maintenance of it. Why is it? It's one number, which is the mix of the 2 things, because it could be an extremely dirty environment that maintenance is done every 6 months. Therefore, you have one result, or you could have the exact same result in an extremely clean environment with maintenance done every 6 years, for example. So the combination of these 2 things, so how often I do maintenance and how bad the environment is, will give me this final ratio. If I multiply these 3 numbers, we get our final maintenance factor. This is...
Thanks, Paolo. I was actually just going to follow up with a question on
okay,
that.
good.
Whose responsibility is it to calculate the maintenance factor?
So the maintenance factor responsibility is for whoever's doing the lighting project, which does not mean that whoever's doing the lighting calculation per se, the simulation, but whoever's setting the parameters for a lighting plan, which could be the operator of the airport in this case, or an engineering consultant working on the project, or it could also be, you know, the manufacturer itself doing the simulation if they have enough knowledge to do so.
So we often get asked, I think because maintenance factor is represented by a number, the number can sometimes seem quite abstract. So what does the maintenance factor actually mean in the form of a number?
So in this case, we mentioned 0.8 a lot. This is because it is, let's say, with LED technology within this sector, which is aviation, it's the most used level of maintenance factor. Because if you run the calculations to most of the airports and most of reputable LED producers, you will end up with a number similar to 0.8. Of course, this is never, you know, an exact number. You could get 0.838312. You always kind of round it up to the closest 0.5. Otherwise, every project will have to get, you know, its own specific maintenance factor, and will make things very long. Generally, you round it up by defect, because you tend to always try to add a little bit extra tolerance to also account for what could be little differences in size from drawings to real life, aiming differences, and all these things that could affect the results of a lighting installation. As we said before here, this number, it means what the theoretical values have been multiplied to in order to reach the results that you see on the light levels page. I can't stress enough how important on the flip side, on the commercial side, this becomes. Because if I'm doing a calculation for an entire apron of an international airport, and I've used a 0.8 maintenance factor to correctly simulate the decay over time and to account for all these things, I will have 20% more lights and power than somebody which is using 1. And that 20% makes a huge difference when you're trying to compare, for example, to different proposals, to different projects. And these, yeah, again, it's light levels and power are heavily influenced by it. the day one light levels should reflect the maintenance factor has been used. So if I have requested to do a project with a maintenance factor of 0.5, I need to see double the light levels of what I'm reading on the page on the day of installation. Otherwise, there is something wrong. There is something that is not gonna change over time the way I expected.
So Paolo, that actually brings us on to, so if the maintenance factor isn't specified, then there will be a problem in comparing different systems. Have you ever, what other misconceptions have you seen in terms of a maintenance factor?
Let's say, first thing, if the maintenance factor is not specified, is not written anywhere on a lighting simulation, all the numbers that you read in terms of results are completely worthless, because they could be half, double, 5 times, because it's literally an input that you type in. So if I type in maintenance factor 5, I'm gonna have 5 times the results 5 times greater, which it's impossible. So actually, if it's missing, it's first thing to do is ask what was used. Some misconceptions that we've seen while comparing lighting simulations, it was we've seen producers using maintenance factors above 1, and being these a representation of a percentage above 1, meaning that you're actually increasing the light levels over time with some magical reason. But the real reason behind doing that was just to try to fake the result and trick, because already maintenance factor 1 is only possible in theory. It's not a thing that exists in the real world. Above 1 means that you're multiply by more than 100% all the input data that you're putting in the simulation. So
it wasn't a mistake, Paolo. Presumably it was just kind of tricky stuff or some kind of fraud.
Yeah, I mean, if you see a maintenance factor above 1, it's generally fraud, or the person doing it actually has no idea what they're doing. Because, yeah, let's say mostly fraud.
Okay, well that will then bring us on to maintenance factor using different settings. You've gone into detail about the role of maintenance factor in apron floodlighting and in the design, but what about in road lighting, sports lighting, or obstacle lighting too?
Well, here we have some examples. Start, for example, road lighting, which has a very similar number very similar, in this case, identical maintenance factor to apron lighting. This is because in a smaller scale, they are subjected to similar environment and similar working hours to apron lighting. So your end results, it's not going to be much different, because road lighting, just as apron lighting, it's on for about 12 hours a day, which accounts 4,300 hours per year. Still with the traffic ongoing below and fuel being burned, whether it is by cars or planes. So your dirt accumulation levels are often similar. And also the technology behind the luminaires, it is extremely similar, even though in a different scale. A modern street light and a high power floodlight for apron, they are made by diodes, electronic drivers, and similar things. The reason, for example, for sports lighting to use a 0.9 is because the hours of usage are extremely lower. They're about 1/4 or even less than what is used in a normal outdoor installation, because sports lighting is only effectively used whenever people play sports at light. So a maximum of 1,000 hours of usage per year. So if you plug this data into our calculation that we had a few slides ago, this highly influences both the maintenance cycle. So every time you do a maintenance, you will only have had a shorter hours of usage between maintenance cycles. And it greatly influences the first parameter of the lumen depreciation of the luminaires, because that is purely linked with how many hours am I using the LED chips for. So you end up with the result above 0.9. Similar thing with obstacle lighting, being generally a redundant product. So you always have a backup light that comes on in case you have a failure. So that eliminates the second parameter, which was the Lyme survivor factor. And also obstacle lights are generally over-spec'd in order to maintain this 32 candelas over a longer period of time. So they start at a higher candela than they are supposed to.
Thanks, Paolo. So finally, where can we actually find the maintenance factor? How can we check that it's been used?
Well, depending on the software used, you will, for example, in Dialux, it's found on a page called Planning Data, where you have kind of a summary of luminaires used, lumen outputs, power. It's always indicated right there. Other softwares might have it in a different position, but it's generally in the summary pages, in one of the first pages of the lighting simulations. And if it's not there, mandatory to ask again, because otherwise you cannot trust any of the numbers you read there, because they could have been multiplied or divided by the wrong factor, and will make a huge difference when you actually go and install this lighting plan.
Thank you. So now the conclusion. Basically, what do we want to say? We want to say that for airport aprons, really the best practice is to use a maintenance factor of 0.8, unless we have some exasperating conditions, which were mentioned before, for example, high level of dirt, debris, very high level of salinity, or anything around which could really impact how the lenses or the glass screen of the luminaires are basically covered. So that obviously is the key takeaway. Another point is that we really should be having a maintenance factor mentioned in any kind of tender documents. If you are putting out a request for proposals, or you're requesting people to come back for tenders, RFIs, please ensure that a maintenance factor is specified. And then let's always remember we should be comparing apples to apples and not apples to oranges. So double check that the different suppliers or different tender responses are using the same when comparing the quotes, because they can be wildly different. I think the main point, though, of all of this that I found interesting is that maintenance factor seems like such a small point in the context of a large apron project, especially some of the larger new constructions that go on. So, is that something that really we should really think about and be concerned with? The answer is yes. It's actually quite critical. And I think Paolo made the point very clear that without it, we can't really rely on the information that we're presented. So although it's a little obscure, a little point, it's highly critical. So let's not overlook it. Make sure we always have it back of our mind. And one of the first things to think about when thinking about a new project is what maintenance factor should be applying. For further information, we do have a technical note on the maintenance factor with the equations, how to calculate it, what are the things that lead into it. This is available on our Knowledge Hub on our website, but I think there will be a link to it in an email that will be shared by Sophie at the end.
There will.
So I hope that's all been educational.
Wonderful. Well, thank you very much to our presenters. Now we're going to go on to a quick poll where we would just love to know what topics you would like us to cover further on in our series before we get into questions. I'm seeing that some people are putting the questions into the chat. If you could, can you pop them into the Q&A box, please? It just makes it easier for us to find them and to answer them. So in a moment, a box is going to pop up on the screen. If you could just vote for any of these topics that would be useful for you or insightful, so we know for the next lot of webinars what you would like to see. Okay. Okay, the box should be up on your screen. I'll just give you 30 seconds. Okay, wonderful. Thank you very much for that. We'll move into the questions now. I can see that you're popping them in. Thank you very much. So first up, we have a question. What standard do you use for deriving the maintenance factor for airport apron lighting? This is a two-parter, but we'll start with that. Paolo, if you could answer that one for us.
Yeah, the standard is not specific to apron lighting. It's a standard to calculate the maintenance factor, which we follow the ISNA, so the Lighting Engineering Society handbook with the RP8, which is recommended practice. And it's this document guides you through picking the correct parameters and compiling the calculation. So starting from the luminaire dirt depreciation factors, which will show you the curves and describes what's a very clean environment, what's a moderate environment, what's a dirty environment. You have your diminishing curves depending on how many years the luminaire is exposed to that, and you reset this value according to your maintenance cycle. And then, well, it shows you where to get your other parameters, which are more product-based rather than calculation per se.
Okay, wonderful. And then part two of that question is, what about the constant light output, or CLO? I giggle slightly because we did have that in the presentation, but we thought no one would ask about it, so we took it out. So Paolo, if you don't mind telling people about
the
CLO.
CLO, which is basically something you can program into your electronic drivers. So the current to which you're driving your LEDs will grow over time to compensate the decrease into your lighting output. Will come into play and only affects one of the three parameters, which is the lamp lumen maintenance factor. So if the luminaire is equipped with CLO, should have its own set of data to be plugged into the maintenance factor, the lamp lumen maintenance factor calculation, and it will raise that number, which again it's always a number ranging between 0.9 and 0.99. So we'll bring it closer to 1. It will not eliminate the depreciation, but it will affect it positively, and it might have an influence on the final maintenance factor. But keep in mind that the other parameters, which are more environmentally related to the environment, are not part of this. So they're not going to be influenced by the CLO. And also the CLO will also result into an increasing power consumption over time.
Okay, wonderful. We've got another question. Someone asks, should you calculate the maintenance factor for each and every area in the project, or can you consider a maintenance factor holistically?
Well, generally, yeah, you do consider it for for one entire airport. You would use a different maintenance factor if you have a particularly different area, but I don't think in aviation is really applicable. But I don't know, in the port, for example, where you have containers, you will have a certain maintenance factor. Then you have an area where you move material in bulk, so you just drag raw material, and you have big piles of dust lifting up. That specific area, you could specify a different maintenance factor. But for aviation, I don't see. No, it's generally just do the entire airport.
Okay, wonderful. We've got one that might be hard to do live, but we could definitely follow up. We've got someone asking for an example of a maintenance factor calculation based on a certain product's data sheet. I think that's one we'll have to follow up with via email.
Yeah,
So
it's not very easy to do in real time, honestly. Yeah, we'll put something together. I mean, we have actually calculations, so can show you. But it's in specifically using certain products data sheet. It started to say that the data you need to look for in the data sheet are the data coming from TM21 projections, so the L90 B10, L80 B20, and those type of lifetime data.
okay, brilliant, thank you. So yeah, we'll follow up with that one. Our next question we've got, thank you everyone, we've got so many. We'll try and get through what we can in the next 5 minutes. When calculating the maintenance factor, will lux level increase or decrease if we increase the maintenance factor?
So when you increase the maintenance factor, meaning you get closer to 1, your first day light levels on the ground will be very close to what you have on paper. When that maintenance factor is decreased, so we get closer to 0, it means that your light levels in real life will be always higher and higher than the one you have on paper. So it is basically the light levels that you read on the paper are a decreased version of what you have in real life, according to whatever the maintenance factor was.
Great, thank you. Our next question is, how do you estimate dirt conditions properly?
The dirt conditions are estimated by the recommended practice 8, the YESNA recommended practice, and divided into very clean, moderate, dirty, and very dirty. Here a little bit, I mean, there are parameters like how many micrograms per cubic meter of dirt is moved, but we all know this is, very nice to write on a paper, but nobody knows how many milligrams of dust is moved in a certain place. Generally, there are common sense is used to determine these things. An airport in Norway, we know it's going to be a very clean environment due to frequent rainfall, cold temperature. When you have an airport on the sea in a tropical humid country or with a lot of sand, like in the desert area, and you're on the seafront, you're gonna be dirty or very dirty, just because the lamps will get covered with humidity every day and you have dust blowing onto it. And so it's comes a little bit from experience as well, not just pure mathematics. And in doubt, always choose the worst case. So if you're in doubt between dirty and very dirty, use very dirty, and you'll always be on the safe side.
Okay, wonderful. Our next question is 0.73 a very conservative maintenance factor? Would that lead to having an excessive amount of luminaires?
It depends where you are. It could be very conservative if the conditions are actually great, or it could be right on point. If I mean, we do projects with 0.7 something, 0.75, 0.7. For example, outside of aviation, if we do a project for crane lighting, for port terminals, those are done at 0.7 because they get quite dirty over time. They don't difficult to reach to get cleaned. So there's no wrong answer. Like, you're gonna have on the first day 27% more light than you read on the paper. So if your lux level it's 20 with the maintenance factor of 0.73, on day 1 you'll be pretty much at 30. So I wouldn't say it's excessive. Yeah.
So Paolo, let me ask a question then, because what we've sometimes seen is certain airports have said, well, we want to ensure that there's no depreciation on our apron from the floodlighting. So we would like to have a starting point of 40 lux or 30 lux, or indeed somebody has asked here, what if we recommend an average of 60 lux? So in that instance, are they already anticipating the maintenance factor by setting a higher lux level, and therefore they can set the maintenance factor to 1?
Exactly. I mean, it is never the correct way to set it to 1, but effectively doing the same thing. So, if I have 20 lux with a maintenance factor of 0.8, and I say, no, I want to be more sure, do it at 40 with 0.8, it's the same thing as doing it at 20 with 0.4.
Yeah.
So that's exactly what the maintenance factor does to a simulation. So this is also to understand why simulations with different maintenance factors are not comparable, because it's like if you compare a simulation done at 40 lux with one done at 20 lux. So you expect one to have done double the lights and double the power.
So in fact, really, if you have a designer or an operator, they should set the final lux levels they want to have at the end of a 10-year period.
Yeah.
So that may be 30 lux at the end of a 10-year period, and then apply the maintenance factor to allow for that depreciation.
Exactly. That's how it's supposed to happen.
Okay.
Okay, we're just going to do one last question. Our last question of the day, what is the duration to take into account for calculating the maintenance factor?
That depends how long you expect to be running this lighting system and how long you want to make sure this is compliant. When we do our proposals, it's for 50,000 hours, which is a variable between 10, 12 years. So we want to make sure that whatever we put up there, it's calculated to work and be compliant for more than 10 years. So that's, but it's an arbitrary decision. I can say, okay, I only care about this apron for 2 years because then it's going to be dismantled. So I'm just going to calculate it that way.
Yeah, there are so many great questions, but I think, Sophie, we're out of time because we don't really want this to run into an hour, do we?
Yes, so anyone who we've not been able to answer live, we will follow up with you in an email, and we'll also send out all those questions and answers to everyone as well, because I'm sure some of you probably want to know the answer to some of the questions other people have asked. But that is all we've got time for today. Thank you so much for joining us. We really appreciate you giving up your time to be here, and we hope that you found everything useful. On the screen at the moment, you can see Natasha and Yuli's details. If you've got any other questions you haven't been able to ask that you would like to, please send them an email. They'll be more than happy to help you. And as mentioned, this is part of a webinar series. So we've got 2 more webinars scheduled. We've got one next Wednesday on lighting uniformity. I will include a link in the email for anyone who'd like to register for that. And then 2 weeks after that, we're doing one on how to specify the best solutions. And with the information you've given us, we will be scheduling more in the future. But thank you again for joining us today. We've really appreciated it. And we hope to see you again soon.
Bye-bye.
Thank you. Bye-bye.
Thank you, everyone.